Hello, everyone, and good afternoon. Thank you for participating in LRVS 2023. Let's get ready to welcome Jaime Borley, Director of Assetivo, to give us more information about dancing with dirty data, steps to smooth the path to asset reliability improvement. Let's go.
Hello everyone, welcome to the Lubrication Reliability Virtual Summit, EMEA 2023. So, I'm Jaime Borley, the Director of Assetivo. We provide asset management services, reliability services, and also condition monitoring services here in the UK. And today I'm here to present Dancing with Dirty Data, Steps to Smooth the Path to Asset Reliability Improvement. So I hope you enjoy the next 15 to 20 minutes of this presentation, and I hope you can get some value from it. So as a brief introduction, with the ever-increasing focus on asset reliability improvement worldwide, asset management professionals, such as myself, reliability engineers, we're turning more and more to computerized maintenance management systems or EAM systems, and specifically the work order history to inform our decision making in terms of improving reliability. So moving beyond the typical Excel spreadsheets, many more modern reliability engineers and analysts are now turning towards data analysis tools to derive insights from that maintenance data. But across all sectors, and I've seen this myself, there's a regular disappointment with the data quality and the amount of cleansing that must take place before the data is usable. This is the dirty data that I refer to in terms of what is really preventing reliability journey progress. So I'm here today to present a way forward on how to smooth the path toward asset reliability improvement, specifically dealing with dirty data in CMMS and EAM systems. First up here, a great quote from Peter Sondergaard at Gartner Inc. So he says that information is the oil of the 21st century and analytics is the combustion engine. So I like this quote really because for three reasons. Firstly, in terms of abundance, in terms of data abundance, we've got so many connected devices, sensors across industry, our smartphones, tablets, internet connections, Wi-Fi. So really data is abundant, so much more than it used to be. Secondly, the economic value of that data in terms of allowing us to improve our decision making and allowing companies to become more competitive with their rivals. And thirdly, the innovation and disruption that the information that data provides. So really data and the information that it gives us afterwards is the raw materials for machine learning, advanced analytics and artificial intelligence. So it really is the oil of the 21st century. So it's a great quote there from Peter Sondergaard. So let's look at some effective tools for the typical reliability engineer or maintenance analyst today in 2023. The more modern, or as time goes on, more and more reliability engineers are using these types of tools. So firstly, we've got Excel, and I think most people are familiar with that. We all tend to use Excel spreadsheets, and for a lot of companies, it's the #1 choice. But we should also now be looking at the use of Python programming language and also R, which is relatively similar. We now have Power BI, which is more and more in use, and also SQL, which has been there a long time as well. So look briefly at those or the benefits of those four types of tools and software programs. So Excel, really, its main benefit is the ease of use. It's a typical Microsoft tool, very easy to use, great interface. And it's good at providing visualizations if you know what to do with the data, using functions and writing programs, maybe in VBA. So a lot of us are skilled already in that particular software. In terms of Python and R, these are software programming languages really, which are very good at dealing with large data sets, at automating tasks, and relatively good at creating visualizations as well. And there's lots of libraries and different things you can use with Python. So very, very versatile language used in machine learning, artificial intelligence, and very much so in the engineering sort of sector. It's a great language to use, and also R. Power BI is another one that's come along in recent years, so very good at creating dashboards and visualizations for management and senior stakeholders. It can deal with real-time data, and again, it's closely linked to Excel, but gives a lot more functionality and a lot more interactiveness, I suppose, with the data. And lastly, we've got SQL, which is really a database management tool. So very good for querying large data sets, joining data sets or interrelated data sets. Very good with real-time data, and also not that difficult to learn once you actually sort of get into it. So there's some effective tools for modern reliability engineers and maintenance analysts, which I would recommend at least learning 2 of those from that list from experience. Let's look at some common problems from a reliability engineer perspective or a data analyst perspective. And I've come across some of these myself, so I felt the pain here. It could be the time required to manipulate CMMS maintenance data. Again, I've been through this process, and I've spent days going through work orders on a particular line of machine, and it's very painful, so to speak. The time required to clean the maintenance data. So you get this maintenance data from CMMSs or EAMs, but you almost always have to cleanse it in some way or another to make it usable in terms of creating visualization and deriving insights. Incorrect assets, so get lots and lots of work orders raised at incorrect assets, ghost assets, or random assets in an asset hierarchy. Work orders recorded at the wrong hierarchy level, very, very common problem in most industries I've been to, in most sectors, regardless of which CMMS they're using or from which vendor, doesn't matter. No failure modes on the work order, so again, how makes it very difficult to make reliability improvement when you don't have a failure mode. Free text field, which is known as unstructured data in the analyst sector. So again, long rambling text fields, long descriptions, and sometimes can be very difficult to pick out the failure modes. Again, makes it time consuming. Poor fault or failure description, so maybe the engineer or the technician is not that skilled in understanding what a failure mode is or how to describe the failure mode. Duplicate work orders, so this again is something I've seen many times when you have multiple technicians working on a breakdown, maybe across different shifts, and they've raised multiple work orders, which when you actually do the reliability calculations months or years later, it looks like there were more breakdowns than there actually were. So again, that is a common problem. And poor analysis skills. So again, we've got reliability engineers who maybe don't have those analysis skills to work with even Excel spreadsheets, Excel data. So that's something that can cause a problem for a lot of different companies. So very briefly, let's look at the importance of good, clean data for us as asset management professionals. So in terms of reliability improvement, good, clean data really is the foundation for studying and improving asset reliability and minimizing downtime. So without good data, we're in a bad place, in terms of understanding the reliability of an asset, the maintainability, the availability of the asset, and how it fails, and information for root cause analysis. So we really need good, clean data. That's a basic input. And secondly, it goes without saying that good, clean data is a foundation for decision making. So it supports strategy, maintenance strategy improvement, maintenance strategy development, and essentially risk management, which is what it's all about, really, managing risk of failure and how to deal with that failure. So what is this dirty data that we talk about? So there's just an image there on the right of a typical work order, a long text work order, as you can see on the right. But let's look at what makes it dirty data. So duplicate data. I just mentioned that if you're having 2 or more work orders for the same breakdown task, multi technicians across shifts, and when you look back in the future, that would appear as multiple breakdowns on the same machine, which will give you incorrect reliability figures, reliability data. Big problem. Incorrect data. So even simple things like spelling inconsistencies, bearing, barring, BRG. I've seen it spelled so many different ways, just that one item or component, So if a reliability engineer like myself is investigating the long text work order, that can add a lot of time to the analysis part or the data cleansing part of the cycle. I've seen false statements, so technicians using CMMS systems for time reporting, time allocation, they're just using as a clocking in and clocking out tool really to cover their hours. So, and when you have that approach and that culture, it tends to make the technicians and the engineers create work orders just to cover their hours, you know. So not good. Deliberate actions, deliberate work orders to stop assets. So again, from personal experience across different sites, different sectors, I've seen operators stopping machines, you know, deliberately so they can take extended breaks, and that then creates false work orders. I guess incorrect work orders. Another one is inaccurate data. So work orders raised at the incorrect asset, as I mentioned. You know, some have been through asset hierarchies in different factories, different sites where they've had ghost assets, incorrect assets, assets that don't exist anymore, but work orders still being raised against them, maybe out of because of cultural issues or laziness. We don't know generally, but that's the cause of inaccurate data that makes the data dirty. Pardon. So we also get work orders raised at the incorrect hierarchy level. So if you take a look at the image on the right of the screen now, we've got 3 work orders on the top right image, raised at 3 different hierarchical levels. One basically at production, way too high a level. The second one at the ovens level, which again is too high a level. We don't know which specific oven. And the third one at oven 1 level, which is right. But we can't even go lower than that. You know, we can go to sub assets of the main asset also. But that is a good example of dirty data. Wrong assumptions about the failure mode. So if an engineer is not trained in what a failure mode is, they can make wrong assumptions about symptoms and causes, again, which clouds the data, makes it difficult for the analyst. We'll also come to worthless data as well. So I've personally seen, as maybe most of you have, many work orders with no recorded failure modes on there. It can maybe left blank oftentimes, or the old favorite, it broke, I fixed it, which is almost entirely worthless really, other than knowing that the machine broke down. We don't know how or what happened, what the repair was. Feedback left blank, seen this many times, even the titles left blank. So again, that's worthless data really to a reliability engineer or analyst. No recorded downtime, so this can affect how we record availability of machines if it's not being recorded through an OEE online system. If you're getting your availability from the CMMS, then this is a problem. Right, so to move on to some common causes of dirty data, we look at it through 3 lenses or 3 perspectives, typical to cause analysis. So we've got physical, human, systemic. So let's look at the physical first, the physical or digital cause, I like to call it. So one cause of dirty data is the CMMS or the EAM system not being set up correctly from the beginning. Maybe the reliability engineer wasn't involved, it was just bought, installed by non-maintenance people and set up incorrectly. Maybe it's just the CMMS or the software itself is inadequate for failure reporting. Maybe it's a sort of legacy system, or it's been around a long time and hasn't really modernized with the needs of reliability engineers and reliability focused companies. Maybe in the CMMS there's no selectable failure modes. So selectable failure modes are what we would call structured data. So not the free text, because this is structured data, so you can actually select failure modes by asset type and component type. So it may be that the CMMS you're using, it doesn't have that structured data or that structured data option. Free text fields, again, as we mentioned, this is unstructured data, so long rambling text, paragraphs of text, you know, when we just can make it difficult to pick out the failure modes for a reliability engineer. Insufficient access to PC laptops. I've seen this a surprising amount of times where you'll have a maintenance crew on shift, let's say 5 or 6, maybe 8 technicians, but only one PC, one computer in the workshop, and no access to tablets or laptops. So again, at the end of the shift, they're queuing up to use the computer, and they often run out of time before they're able to raise their work orders. And from a human perspective, let's look at the common causes. So firstly, untrained technicians. Now this is quite common in industry. We've got untrained maintenance technicians and maintenance engineers, maybe because of company culture or lack of a budget, but you often find that they lack training in the CMMS or the EAM system. Disengaged technicians also, so this probably again comes back to company culture. They don't understand the value of what they do or the data they have to collect. So you get that cultural disengagement. But again, this can be solved, at a systemic level. Quite often the engineers and technicians are under time pressure from operations or engineering, to spend more time on the line to actually continue that cycle of firefighting, and they maybe don't have the time to raise good quality work orders with good quality data. It may be that within the maintenance crew, the maintenance team, there's a lack of understanding of what a failure mode is. What is a failure mode? What does it mean? And where should it go on a work order? This is what we call, or what John Reeve calls, the language of RCM. So there could be a lack of understanding there. And also a lack of understanding of the value of good data. What is the point in having good data? Maybe they don't understand that long-term strategic importance of good clean data and how it can help with reliability improvement and delivering the most value that we can from our assets. To move on to the systemic issues, so if we look at the deeper, more systemic or endemic issues to companies, we look at things like lack of leadership and buy-in. So sometimes reliability may be seen as a flavor of the month. Maybe it's not even considered. I've seen this often in companies which have been family-owned, family started up, or started by entrepreneurs. They start a production quickly. It's all about getting components, getting products out of the door, and no thought really is given strategically to maintenance and reliability and asset management. So maybe sometimes you lack that leadership and that buy-in to the more strategic, longer term structures and frameworks that are required for professional asset management. There may be a lack of investment because of that lack of leadership or that lack of buy-in, that lack of understanding. There's a lack of investment, so maybe there are no budgets for a professional CMMS, for training, for hardware, software, sensors, even for a reliability engineer. There may be no investment for that. And often as a result of the previous two, you get those inadequate processes and procedures which are not in place, but they need to be in place if you want to do professional asset management and deliver long-term value from your assets. And that means collecting good, clean data and having people trained and the processes in place for all those good things. And as I mentioned just now, that it may be because of that lack of investment that a lot of companies don't have reliability engineers or analysts. You see it sometimes in the food and beverage industry where it's seen as an extra expense, and maybe they don't see it as a requirement. But I've seen it across lots of industries where there are no reliability engineers. Systemically also, maybe no standards are used in terms of the ISO reliability standard 14224 or the asset management series ISO 55000. So there are lots of industries that are still late to the party in terms of this, and it's you see it in industries like the water industry, for example, strong use of the ISO 55000, but it's gaining popularity slowly across industries. But again, systemically, it's an issue if those type of standards are not in place. So to round off, let's look at some steps I believe you can put in place to smooth the path to asset reliability improvement. So let's look at strategically first, and this is really addressing those systemic issues I always say. So strategically, you need that leadership and buy-in, because leadership, well, they lead the way, and they can champion reliability and data collection. And if it's coming from the top of the tree or the top of the management, so to speak, then that will filter down through the management levels, down to the shop floor, to the technicians and operators. But you really need that if you want to improve asset reliability in the long term. It has to be in place. And with that comes the investment. So if you have plant managers and business owners really leading and bought into the need for long-term asset reliability and professional asset management, then you will get that investment. leadership will invest in those reliability processes, asset management processes, and collecting data and converting it into information through analytics. So that investment needs to be in place as well. And thirdly, once you've got those first two in place, then you definitely need processes and procedures in place. So this is the foundation, the structural stuff. When you get these processes and procedures in place and the people bought into it and understanding their roles and responsibilities within that framework, you can set them up, to have repeatable inputs and outputs, understand and used by all and everybody at the company. Fourthly, once you have those processes and procedures, and in tandem with those, really, you should be using standards. So I would suggest, from a reliability perspective, using the ISO 14224, which is the reliability data collection standard, which was created for the oil and gas and petroleum sort of industry, but it's definitely usable across almost all industries. And I've used it myself on many occasions to set up sort of data collection systems and asset hierarchies. But also, if you're really sort of strategic and forward-looking for long-term value, then use the ISO 55000 series of standards. You don't have to be, get audited and become certified to those standards. Need to be in place for good asset management and professional asset management. And fifth, and this is a really important one to me, is that if you're in the process of purchasing a new CMMS or EAM, you really should use a reliability engineer, someone skilled and knowledgeable in reliability or asset management broadly, to influence the purchase and the build of the new asset hierarchy and the PMs and all and the spares and everything that goes into it. So get that person involved from the very beginning. That's a big one for me. Yeah, which I've seen many times as a failure across many sites. So it's very, very important. So let's quickly look at the five tactics that we can use. The first one, this is the kind of stuff that you can do quickly, I believe, rather than the more strategic. You can get a lot of this stuff done quite quickly. So I think the engineers and technicians need education in work management to understand, the bigger picture of the work management cycle and how they take part in that and why they are so important to that cycle. Again, really important, that educational piece. Number two, I believe they also need education in failure modes, the language of RCM, as John Reeve says. It's surprising how many blank faces or blank looks you get when you ask technicians and engineers about the failure modes, when they worked on a breakdown. So it's really good that they should understand that and be conversant in the language of RCM, reliability-centered maintenance. Thirdly, I believe they need education in the value of the data. So, we're asking them to collect data, which is to be converted into information in this modern world of the industrial Internet of Things, I 4.0, which is a lot of sensors, a lot of data being collected, but there's also excellent data to be collected from the engineers who worked on those breakdowns. So they need to understand the WIFM question, which is what's in it for me. So we need to put that across, so how they're so valuable to the process, the work management process and the analytics process, the data that they're able to provide. And so for number four, in terms of the CMMS, you really need a robust, accurate asset register. It's a critical foundation. So this is what I talked about earlier about ghost assets and incorrect assets, badly labeled assets. Get that right from the beginning. A really good asset register built using the ISO 14224 standard. That is critical. So please do everything you can to get that right from the very beginning. And if you're buying a new CMMS or look at what you've currently got, make sure it has selectable failure modes or a way of collecting structured data. So when the technician, the engineer works on a breakdown and records a work order, then they can go into the work order screen and select the asset, the component, and hopefully the failure mode, failure cause, or something as similar as possible to that. It'd be great if you could have a specific machine with a motor and then a drop-down list of typical failure modes. Maybe the top 10 or the top 20. That they can record. So that is the real structured data that we're looking for as analysts and reliability improvers. And lastly, which we touched upon earlier, give them easy access to PCs, laptops, and tablets. Remove those barriers to progress and efficiency. So I don't see any reason why, you know, modern maintenance engineers and line technicians, maintainers can't have their own laptops or tablets to use at the line, because this is the way the industry is going. You know, we need to remove those barriers and make it easier for our maintenance teams. So to round off, these are just a couple of resources for further reading. So if you're looking to get on this path to asset reliability improvement, specifically using maintenance data and maintenance insights, I'd recommend these three resources. So firstly, we've got the Institute of Asset Management's Asset Information Strategy Standards and Data Management documents. Some really good information in there. Not particularly expensive as well. So I'd recommend becoming a member of the IAM and getting hold of those documents. Really good. Secondly, I mentioned the ISO 14224, which is the reliability standard really for collection and exchange of maintenance, reliability and maintenance data for equipment. Again, it says petroleum, petrochemical, but it's really applicable and usable across pretty much all industries that I've worked in. And thirdly, really good book from John Reeve and Derek Borley in the US is Failure Modes to Failure Codes. So really good book, not a particularly big book, but some excellent information in there, and very easily readable and applicable to most manufacturing and sectors and maintenance departments. I would highly recommend those three, plus the ISO 55000 standards if you're going along that path. So that rounds off the presentation. Thank you very much for listening. It's been a pleasure. I wish I could talk for a bit longer on it, but if you need to get in touch with me, my website is at assetivo.com. Lots of information on there, case studies, and the services I provide both in the UK and Europe and further afield. My email is there, so I'm Jaime Borley at assetivo.com. So thank you very much for listening, and it's been a pleasure. Thank you.
Well, that was the recorded session from Mr. Jaime Borley from Assetivo. So if you have any question directly to him, you can email him, and I'm very sure he will respond to your emails. Thank you for participating in the session, and we see you in the next one.